G'day there guys, welcome back in my shed. I'm BC. Sorry about the delay, been tied up with a few things, mainly the boss lady's back in town. So I've got to pay a bit of attention. A couple of things come up. During the week I saw another fellow post up, can you repair cast iron engine mounts for a tool and cutter grinder? And there was only a small pile of crap about that wide posted up there. I personally have done it there, and it sort of caught me a bit by surprise. I've been selling the product for probably 30 years beforehand, and I came to use it myself. 30 years? No, probably 20. This was repaired about 20 years ago when it's lasted that long, so yes, it is a reliable procedure. Lots of bad advice. Look, if you're electric welding cast iron, there's two types of rod. There's nickel 55 and nickel 99. 55 is your closest to a true cast iron repair. However, it's not very machinable. You've got to grind it, that's about all you can do. Nickel 99, in my opinion, wets in a lot easier. It's machinable. That is, I think, what I used here, and we'll test it in a sec with a file to see whether it's easy to file or difficult to file. I did find it unusual to do. Normally, the old rule of thumb, this is from the end of the electrode to the work push piece should be 1 to 1.5 times the electrode diameter, and at that arc length I just could not get it to wet. I couldn't get the electrode to run reliably, and it was a good brand that I've been selling to everybody else for a while, and it was just in my disgust as I gradually brought the electrode away instead of disengaging the electrode. As soon as I got to about 2.5 or 3 times the electrode diameter, the arc just lit up and went in beautifully, and it did a wonderful repair that I will bring you in and let you have a look at close up shortly. So there are some rules. Whether it takes longer for the arc to raise the shielding gas, the CO2, or not, I don't know. But the repair went in quite well, although I have to say this particular repair here was a little unusual. It's a very soft iron, probably more like Durabar than cast iron. It didn't have a hard skin. And what happened was, for some reason, and I can't remember why, I had to dismount the motor. And this bolt wouldn't align, so I just gave it a slight tap with a hammer. Yeah, I know, should have been a plastic hammer. And it just broke off, and I looked at that, it's 12mm section. And it just snapped, and I thought, bloody hell, what a POS. I wanted the machine up and running ASAP, so I just mounted it up, heated it up with a map torch, and stick welded it, and it come out beautiful. And now I'll swap specs, which I should have done before I started ranting. And we'll find out what grade of electrode it was. Yep, that's filing fairly easy, as is the cast iron. So I'd say it's nickel 99 and very soft malleable iron or soft cast iron. So I'll bring the camera in, zoom in, give you a close-up. We have got a few other things to do today. I've dropped the Workhead down off the riser block, and sorry that it's cramped today. I've got the table with all the tools over here and it's pouring rain, so I can't really take the rider mower out. I've got a DTI up there, and I think I have a problem with flex between the base and the table. So I'm getting up a couple of hundredths of a millimetre there, and surprisingly, the old bearings that have only been in it for about 30 years must be a bit crooked, because I've got probably almost 0.1 millimetre. However, that's not as bad as you would think. Every time you index, you're holding the cutter back against the indexing finger, and that preloads the spindle a little bit sideways, but when the force of the grinding exceeds your pushback from holding the tool, that's when you'll start to get chatter, and that chatter is mainly noticeable on bigger diameter tools where you get a lot more torque on the workhead. But first off, zoom you in on this cast iron repair. Okay, get out of the light, zoom you in on what I've done. Another thing you can do to pick up what electrode was used is the colour. When you get up close, you can see that that's a nickel colour. very, very yellowish from the rod. If it's cast iron electrode, it'd be a grey electrode there. But you see along the edge, it's wet in. Absolutely beautiful. There was one run there, one run there, in position where it is right now. It has been sitting there, as I said, for over 20 years probably. I was absolutely surprised that it broke, and I wouldn't be outlandish to say that these ears might have been bent after they were cast, and there was a lot of tension on the bend there, because this is a eye, and I think the eye was formed after it was cast. But anyway, that's the sort of wetting in you can get. I'm pretty sure that was a 2.5mm electrode, which is too small for that job. But if you get up to 85 or 90 amp, it would wet in. But don't be scared of doing this sort of work. You do need to preheat. That is an absolute must. And for a job like this, I would not use a big weld or a whole lot of current. And that's why it was done in 2 sections. Small preheat, just 1 stitch. Let the whole job cool down. Small preheat, finish the job, and that's it. And there's no weld on the inside or anything. I didn't dismantle it. And that's been living there for quite some time. Okay, we'll bring you around to the workhead and do a bit of a discussion there. Okay, that's in frame nicely. I'll put a Allen key in and use that as a lever. And if you can still see, yep, the dial gauge is still visible. You can see that it'll readily pull up a couple of hundredths of a millimetre in each direction. Now, I've got the dial indicator on the table itself. So what we're actually measuring is the flex at the base, or between the base and the body. So I don't think it's on the clamp at the top here. That's fairly tight. These bolts are nipped up fairly well. So I've got a little bit of play there. And if I move the indicator across, that should do it. You can see that there's a very easy, I'd say about 2 thou in the old speak. So that's between the table and the spindle with very little force put on there. So as I was saying, when you index this around, even if you're indexing at the front at the cutter, you index back against the finger. That will offset any slop that's in the bearings inside the workhead, but it all depends on the grinding forces. And when the grinding forces exceed your pressure that you're exerting, that's when you're going to get the chatter or the flutter or vibration. So what I'll do now is clear a bit of crap off the bench and take up the workhead apart and the bracket. And I've only got a master straight edge that's 1 metre long. I've got nothing smaller of any consequence. But we'll try to see if we've got any concave surfaces here. So instead of contacting just on the periphery of the circular piece, it's contacting on the inner part, because the outer part is worn with age, and that allows it to rock a little bit. While I've got you here, I'll bring over some work pieces from last week, and we'll have a look at a different type of indexing finger. Lucky I remembered that. Okay guys, what we have in focus at the moment is a Clarkson indexing finger. It's called a drop neck or a gooseneck finger, and this is quite a good view because you can see how easy it is to fabricate something, just a couple of bits of flat bar, although you want the boss to be a bit bigger than the flat bar. Over the back it has a grub screw to locate the indexing finger. It means it's fairly limited in where you can use it, but it's not too bad. It's the sort of indexing finger you can bolt on top of the workhead, or if the mounting pad is on the other side, as long as the flutes are equally spaced, you can index off any other fingers that are available. But that's quite a neat version of it. The item that came with the long foo is this big Brutus. and I've been using it as a cast iron parallel to use with squares to line the flutes up on the actual relief attachment. But it's a much bigger version of the same thing with a movable finger at the end, and this isn't the original indexing finger. This is one that came with the Haro grinder. Now, I was quite surprised, and it's something that I hadn't thought of. A lot of the text, including the Clarkson text, talk about using the indexing unit off the table underneath the cutter. And it's always bloody short. And you scratch your head, how the hell are you supposed to use it? Well, I got a copy of the Wrong Fu owner's manual from Mr. Heron Forbes. Thank you very much. And the response was quick. It was probably only about 12 hours, and I had the copy emailed out to me, so they're good with their backup service. But it shows a tower for mounting the index finger on, like so. Too tall, you say? Well, not always, depending on the cutter. But the tower they had was one piece. I had a piece of material, and I made my tower out of many pieces. So it makes it a much more adjustable indexing finger, and I can now use the same contraption over on the Clarkson to make this indexer more flexible. So yeah, it's something that you learn. Like I've been using these machines, or this one in particular, for over 20 years, and it was only last week that I learnt this. So that'll be another item you can put into the book. Very easy to manufacture. 2 pieces of flat bar, a couple of bits around, and you've got an indexing assembly. A lot of people lie on their side a little bit too quickly. They say, oh, it's too hard to make a workhead or whatever. These items are extremely easy to fabricate. And I've got to say, you don't have to be 100% accurate because you're only grinding at one point. It's different to surface grinding, and it's vastly different to cylindrical grinding. Tool and cutter grinding, it doesn't matter if you're a thou out on the face or it's a little bit concave, etc. As long as you can set it up and do the job, it doesn't really matter a rat's bum. And a lot of that means that you can make this stuff yourself. It's very easy. Okay, having said that, I'll try and clear a bit of room on the bench, and we can break this workhead down and have a look at how bad it is. Okay, we've got the workhead apart. And this will be interesting for anybody that wants to build a workhead. You can see the component parts aren't that bloody difficult. I didn't find it difficult when I built that Clarkson style drill and tap grinding attachment, which is in my video list or playlist on tool and cutter grinding. And if you build it out of components, it's not that hard. Now, that is one of the harder parts to make. It's a 3 Morse taper to ER32 chuck, and without the collets from MG Productions down in Victoria, I think they're about $38 for the body and the nut. Now, you have to be a bloody dill to think about building something like that yourself, but that's really quite cheap. And the run out on the body and a plain shaft in the collet is down to about 0.02 of a millimetre. So yes, that's quite an acceptable item. A bit more room on the table now. Now, in from the back of the workhead is just a bolt with a boss, and that holds or retains the body inside the shaft or the spindle. Cast iron spindle, but it could be quite easily fabricated out of a bit of solid, as I did. We'll take this apart later on, I think, and have a look at those bearings, or at least can we adjust them. But yeah, quite easy to fabricate. It's in very good condition for its age and for the worker stud. The amount of maintenance my staff gave this machine was less than 0, if there is a possibility. Now, this particular item, the bracket itself, can be fabricated out of a bit of heavy wall pipe, about 75mm diameter, flat material for the base, piece of solid for the upper boss, but you can make it any configuration. But there are a few things in a commercial item that you might not realise. The centre line for the pivot point is not the centre line usually for the lower pivot point. And the reason for that is, if you turn the bracket 90 degrees, you can gain an inch in either direction. And sometimes that's crucial in getting your workpiece up to the wheel to face it the way you want it to. Also, you'll find that it's offset in this direction. And that was something that took me aback when I first got this unit, because it means you've got to crank the table in and out as you pivot a annular cutter to go on the inside or the outside facet. But once again, that also gives you a bit more adjustability. Now, what are we going to be checking? Well, we'll look at this surface here and see how good it is. We'll clean it all up, give it a bit of a scrape to get the crap off it, and see if it's flat. We'll check the corresponding surface here. What you don't want is for all of these surfaces to be contacting on the inside only. That means you have a fair amount of dead area, and these items usually wear on the outside. So you finish up with a joint that's fairly flexible because there's very poor contact. So we'll be checking this surface here. And underneath there as well. It looks very much like it's been relieved here or here, because it looks like it's only been contacted on the outside. But we'll have to prove that and see how good it is. That ring looks like it's affixed to the body, probably shrunk on. And also there's a bit of rust on the inside there, so I don't think that's been in contact. Of concern to me is this surface here. I don't want it to be contacting just either side of the groove. Yeah, with the amount of shit that's on there, I would say it has not been contacting outside. And these pieces are solid, so I'm going to have to set that up, I think, in the milling machine and fly cut both sides and make sure that it contacts on the outer edge, not just along the centre. And I think it's been contacting there, and yeah, there's dirt there, and there's dirt here, and that's why we were getting that little bit of tip, that couple of hundredths of a millimetre either side. So we'll definitely be able to stiffen that up. Now, if we can stiffen all of this up, the slot that we will have will be in the table, in the V-ways. I don't know whether I'll take the table off and have a Captain Cook down there. But we should be able to improve it and make quite a nice machine. And I'm certain we're going to improve it, having seen the crap that's out here. Yeah, we can't go by what's on the table because that's from the riser block that's been there for years. Well there guys, that'll have to bring it to a close. A couple of minutes. Just thought you'd like to see how we're progressing with Mr. Wrong Fu. And straight away we've come across a couple of items that need a little bit of a clean up. I wish I had the Koons borer running because it's ideal for facing out on flanges and getting things running reasonably concentric, but worse luck, the wiring job's been held up. I've been waiting for some wire and bloody crimp lugs for 3 weeks now. Anyway, that's just a fact of life. It's pouring around at the moment, as you can probably hear, so this will be a bit intermittent, and I have quite a lot to do. I'm now starting to get quotes to sheet in the carport and double the size of the workshop, and I'll no longer be slipping arse over head on everything all the time. It's been a real cat and mouse chase ever since I moved here. When we first got here, everything came out of the trucks and just got shoved into the shed, and it was such a job to get shelves up and just get everything out. Now what I'll do is dismantle the items. If I can pick a few interesting clips out of what I find, I will. As I said, I've got one master straight edge, but it's a bloody huge thing, so it's going to be awful to try and put that across it. But we'll see what we can do with straight edges and feeler gauges and find out how much wear we got there. And might be a job on that base to put it up in a shaper. That way I can face out either side of the T-slot sections to slip into the T-slot, and I can even tip the base up with a bit of shim by a thou or a thou and a half and just make it slightly concave, so make sure it does touch out on the outside edge. I don't know whether I'll do that or make it flat. Anyway, please like and subscribe if you haven't so far. I won't do a long 2-hour video on this because that can't fit in with the schedule I've got at the moment with the shed and everything else I've got going on. But also, I might have some other work around the shed that will be of interest. So, rightio. See you next video. Bye for now.